Welcome back. We're writing Little Man Computer in C++, and we've nearly finished the little man's parsing of an individual instruction. We just have the branch instructions left to go, and then we'll be able to move on to dealing with multiple instructions and the like. So let us see where we're up to. So we've done add and subtract, and if we look down here, we have done add, subtract, store, load, input and output. So we just have our three branching instructions left to go, and that's let's have a quick check. Set the program counter to the given address. That is, yes, okay. So there's no no need to reach into memory for these. It's just interpreting the address part of the instruction directly as a parameter. Good. So we can start by writing a test for unconditional branch. So little man interpreting branch instruction results in program counter being changed to address. To do that now. So we'll assert that address 7 doesn't make any difference. Computer program counter, is that how we've done it? I'll check in a second. Let's create a computer so we can make sure. That looks okay. And yep, and the test fails as we would expect it to do. So then we can create a running man. Like so. That should still fail. And indeed it does. And we know the program counter starts at 0, as we've tested for that, so we don't need to do anything to initialize that. So we can just straight away just say our program, which is going to be 600s, is it? Yes, 600s, so 607, and then a halt instruction, and that should be sufficient as a test. It should still fail, of course, because we've not implemented it yet, and we'll see what that does. Yep, still fails, okay. And then we can edit and handle the instruction type 6. And in fact, now we've done this little bit of refactoring, it's probably easiest just to deal with it straight away here, like so, and then say computer dot branch 6. That should pass the test if we've done everything correctly. Oh, it doesn't. That's because I think I've typed in the wrong. Yes, it was in my brain after the instruction type. That should of course be 7. And should pass the test now. And indeed it does. We have that duplication of the 7 all over the place, but we can just say address here, which is better anyway. And that should still pass the test. And indeed it does. Is there any refactoring that needs doing here? Not at the moment. At some point we might be better to deal with this as a switch statement, as if it's like other languages. Switch will be a constant time operation rather than the linear sequence of checks from an if-else branching structure. But we'll leave that, I think we'll leave that for now. We do have these 2 special cases of input and output. That said, they're both instruction type 9 with effectively address 1 and 2. You could think of those as the addresses of the input inbox and outbox. But we will continue here and get to the end of the branching, I think, first. So I think it's branch if 0, indeed it is. Next, so we can little man interpreting branch if 0 instruction with 0 result. Results in program counter being changed. So assert are equal, and let's use address 8 this time, and let's move a little bit more quickly now, as I think we understand what we're doing reasonably well here. Like so. We do need the accumulator to be 0 explicitly, and then we can have a program in our memory which says 708, and maybe do a memory halt. And we'll see that fail, and in the correct manner. So now we can implement that as instruction type 7. That's branch if 0 address. And that should pass the test. No, we don't have to write another test here for branching, for not branching if not 0, as that functionality isn't actually being handled in the parsing. That's in the branch if 0 operation itself, and we're just checking that the instruction is being parsed correctly and the call is being made through, which we've done in this single test. So it's okay not to have an additional test for that, and in particular we wouldn't, as things stand, be able to write a failing test for that anyway, because the current structure would pass automatically. So we can move on to the final branch if positive instruction. Branch if positive instruction with positive with a negative flag not set results in program counter being changed. Some very long names of tests here, as we've already highlighted, and at some point we might want to rephrase some of these, but for now that's fine. Computer program counter, and we can create a computer. We can have the man run. We can then create a little man, like so. We can then make sure that the negative flag is false and write a little program in the 800s, like so. And we should be able to see that fail in a sensible manner. And indeed it does. And we should be able to implement that relatively easily. Like so. And that should do the right thing. And indeed it does, it passes the test. So we've now got the 3 branching instruction types here. And the possibility of refactoring is quite tempting. What I will do as a refactoring, though, I think, is just move this into a more sensible place in this gap here. I'm not changing the behavior at all. We're just making the code look a bit nicer. That should still pass all of the tests, and indeed it does. But now we have these in a more sensible structure. Let us just have a quick look at what a switch version of this might look like. Let's save our position there. So we switch on instruction type. I'm just slightly making up the syntax here, as I don't really know what it is. Case 1. Do we have to have like this? Add address, like so. I kind of get the feeling that that's the more traditional formatting. Don't know if it'll... no, it wants it to be like that, it would appear. What I am going to do, just to check it works, is put it inside here. And that should give us an indication of if it's doing the right thing. Yep, that still passes. So what I can do is get rid of these bits here, put that all the way at the bottom, like so. And we should just be able to change these else ifs for case things, can we do that in a straightforward manner? Else if instruction type equals slightly uncertain here, but it's an easy check. Does that get the job done? Yes, it does. That's quite good, isn't it? And then we should just be able to reformat that. And we just need to do a little something extra here. I suspect that we might need some break statements to avoid everything falling through at the bottom. And this wants to be something more akin to that, I feel. Although both are equally valid, although somewhat repetitive. So we'll know in a second if we needed breaks or if that's broken everything horribly. No, we do need some breaks in here. So we can, in each of these, put a break statement like so. Oh dear, no, not quite. And we'll find out in a moment if that's worked. And indeed it has. Excellent. So that's now been converted to a switch on the instruction type, which should be slightly better. Excellent. And we shall commit our changes there. And add little man interpretation of branch instructions. Excellent. And then next time we can move on to handling other aspects of the little man's operation.